In this video, we are going to talk about translation of a graph. That we have a function y is equal to f of x and we want to sketch it. So for this, we will first pick an example. We want to sketch the graph for y equal to x square plus 2. We know a regular method of sketching the graph, that we take x-axis and we take y-axis. Here we have origin. So we take x values of our choice. Let's say we take 0, x as 0, and we plug it in the function y equal to x square plus 2. 0 square plus 2 gives us 2. So at 0, the y coordinate is 2. Let's say it is marked here. When we plug x is equal to 1 in x square plus 2, we get 3. And let's say it is marked here corresponding to this 3. And if we take a negative value, let's say it is minus 1, and we plug it in the function y equal to x square plus 2, we get minus 1 whole square plus 2, which is 3. So we roughly have a point here. So let's join these points. So rough shape will be this. So this is the shape for y equal to x square plus 2. And look at this 2 on y-axis here. At 0 x, the value of y is 2. So we can sketch the graph by taking different x values. We get y and then we get the points. We join those points and we get the sketch of this graph. But we can also sketch this graph by using another method. This is the function that we have to sketch the graph. But first of all, we will sketch the graph of only y equal to x square, and we are going to call it as the base graph, y equal to x square, because we know that the y equal to x square graph is pretty basic, which is a parabola. It is this one, y equal to x square at the origin 0. So now we need to sketch the graph for y equal to x square plus 2 and see that how did we get from here to here, what mathematical change did we make. On the right hand side, on x square, completely we are adding 2. So what we are saying is, on the right hand side in the function f of x, if you add a number, then the graph, this graph is shifted 2 units upwards. So what happens is, so again we are considering this graph and we are shifting this graph 2 units upwards, because in x square 2 is being added. So the shape here, so you start shifting it from the origin. So first you mark 2 and shift this same graph at point 2. That would be the shape of the graph y equal to x square plus 2. So in the same way, let's say if you have to sketch the graph of y equal to x square minus 2. So first of all, you sketch the graph for y equal to x square, which we are going to call the base graph. So you know the shape of this graph, which is this one. This is the shape for y equal to x square, and its origin is here, right? But now you have to sketch the graph for y equal to x square minus 2. So how did you mathematically change y equal to x square to x equal to x square minus 2? So on the right hand side, from a function, this time instead of adding 2, you have subtracted 2. So once this happens, so what you do is you shift the graph. Which graph? This one. You shift this graph 2 units down, because you are subtracting 2 from this function x square on the right hand side. So start shifting it from the origin is this. For this function, the origin is here. You bring this graph 2 units down. So 1 unit down is minus 1, another unit down minus 2 unit is here. So the same shape, but the origin is shifted now to minus 2. So this is what you get for y equal to x square minus 2. So if on the right hand side of a function f of x, in f of x you are adding 2, the graph goes 2 units up, and if you are subtracting 2, the graph comes 2 units down. Now let's look at another example. We want to sketch the graph for x plus 2 whole square. Now of course I can sketch this graph by taking different x values. You get y's, you get the complete points, you join those points and you get the shape of the curve. But we are again going to draw the shape of this graph by looking at the rules of the translations. So what we are going to do is, first of all, in order to sketch this graph, I will again write the base graph. So the base graph here is y equal to x square. You know the shape of this graph, which is again the parabola y equal to x square, and its origin is here. Now I need the graph for x plus 2 whole square. So how did we get from x square to x plus 2 whole square? So we are thinking in x 2 is being added. So whenever you make a change in x, specifically if you add a number in x, so your graph is shifted 2 units left. Remember in the previous example, when we had y equal to f of x and we had to sketch the graph for f of x plus 2, then we shifted the graph 2 units upwards because 2 was being added. But in that case, in a complete function f of x, 2 was being added. But here in this case, we are not adding 2 in the complete function, we are adding 2 only in x. So whenever a change is made in x, the graph is shifted 2 units left. Means when a number is being added in the variable x, you shift the graph 2 units left. So what we do is, which graph we are going to shift 2 units left? This one. So first we will have y-axis, x-axis, and we have to shift this graph 2 units left. So this is the origin, -1, and this is -2. So the same shape, but the origin is shifted 2 units left. So that's the shape for the graph y equal to x plus 2 whole square. Let's say now you have to sketch the graph for y equal to x minus 2 whole square. Again, first we will consider the base graph only, and the base graph here is, the base graph is without this -2. So the base graph is y equal to x square. We know its shape, which is this one, y equal to x square. And now we need to sketch the graph for y equal to x minus 2 whole square. How did we get from x square to x minus 2 whole square? By subtracting 2 from the variable x. See, we are not subtracting 2 from this x square whole function. We are subtracting 2 only from the variable x. So whenever a change is made in the variable x, we have to shift the graph either on right or left. If a number is being added in the variable, you shift the graph to left. If the number is being subtracted from the variable x, you shift the graph 2 units right. So -2 means you will have to shift the graph 2 units right. So which graph? It is this graph, which we are going to shift 2 units right. So you always start shifting from the origin. Origin is here, 2 units right, 1 unit right is 1, 2 units right is here. So from origin you shift it to 2, so you get this shape, which is this one. So this is the shape of the graph y equal to x minus 2 whole square. Okay, so we can also look at a third example here. Let's say you are being asked to sketch the graph for y equal to x absolute. Okay, so it's the easier one. You take x-axis, you take y-axis, and the shape of this graph, if you take different points, you will get this V shape. Okay. Now, if you are being asked to sketch this graph y equal to x absolute plus 2. So, in this case, did you make a change in the function, means on the right hand side, which is x absolute? Did you add a number in the complete function? Yes, we have added a number in the complete function. On x absolute, we have added 2. So whenever you add a number in a complete function on the right hand side, the graph is shifted upwards. So you are adding a number, the graph will be shifted upwards. Which graph we are going to shift upwards by 2 units? It is this graph. So we sketch the graph. So on 2 units from origin, 2 units upward, it is, let's say it is 2, and then the shape would be, it would be the V shape. So this is the graph of the function y equal to x absolute plus 2. Let's say you have to sketch this graph now. Now, is this the change in a complete function? Are you subtracting a number from a complete function on the right hand side, or you are subtracting the number from x only? Definitely it's the change on a complete function. That again here on x absolute, from x absolute you are subtracting a number 2. So whenever from a complete function a number is being subtracted, on the right hand side the graph shifted 2 units down. Which graph? This graph, y equal to x absolute graph, it will be shifted 2 units down. It is minus 2. Then you will have this shape. It will be this. So this is the shape of the graph for x absolute minus 2. Now, again, let's very quickly sketch the same graph, y equal to x absolute. You know that it is V shape. And its origin is here. But now, this time, we are going to sketch this graph. Now, from here to here, is it a change on a complete function on the right hand side, or is it a change in the variable x? Definitely it's the change only in the variable x. So a number is being added on the variable x. So whenever you are making this change, the graph shifts either right or left. But when a number is being added, the graph shifts 2 units left. So if in this graph the origin is 0, it shifts 2 units left, which would be minus 2 here. So V shape, but the origin is shifted, so it will be this. So that's the shape of the graph, y equal to x plus 2 absolute. But let's say now you are being asked to sketch this graph y equal to x minus 2. So from the base graph, which is x absolute, how did you get this one? X minus 2 absolute. Is it a change on x absolute completely, or is it a change only in x? Definitely this one is the change only in x. So we can, and whenever there is a change only in the variable x, either the graph is shifted left or right. But in a specific case like this, the number 2 is being subtracted from x, so we will shift this graph, which graph? This one, y equal to x absolute, from origin to 2 units right. 1, 2. So 2 units right, this graph, reshape, but on 2 units right. So that's the shape of the graph for y equal to x minus 2 absolute. Okay, let's consider one more example. Let's say you have to sketch this graph. By recalling all the translation of the graph rules that we have just understood, we can sketch this graph in different steps. So this is the base graph, and I know the shape of this graph, which is this. So now from here to here, we get to y equal to x minus 2 whole square. So how did we get from y equal to x square to x minus 2 whole square? By subtracting 2 from the variable x in this equation. So we know that whenever a change is made in x, specifically when a number is subtracted from x only in the shape, the graph is shifted 2 units right. So this graph, whose origin is here, 0, so this graph is shifted 2 units right. 1, 2. So its shape is this one. But now from here to here, we get to y equal to x minus 2 whole square plus 3. So in this complete function, we are adding a number 3, and we know that if we add a number on the right hand side of a complete function, we shift the graph. Which graph? This graph 3 units up, because this is the shape of the graph y equal to x minus 2 whole square. And to look at the shape of the graph y equal to x minus 2 whole square plus 3, we shift this graph three units up. So at the moment for this graph, the origin is at 2. So in this shape, here in this shape, we shift this graph 3 units up from, so we will start shifting it from 2. 1, 2, 3. So somewhere here, this is 3. So that is the shape that we get. So this is how we sketch the graph for y equal to x minus 2 whole square plus 3 in 3 steps. So we can recall all the rules of translations, that when a graph is shifted upwards, downwards, right and left, and then we can apply when we are sketching the graphs. Just to recall what we did is, so if you have a function y is equal to f of x, you know its shape. Then if you are asked to sketch the shape for y equal to f of x plus 2, so this shape will be shifted 2 units up, or we can say that the graph is translated 2 units up. And if you have to sketch the graph for f of x minus 2, remember you are subtracting 2 from the complete function, so your graph comes 2 units down. You always start shifting your graph from the origin. And if you have to sketch the graph for f of x plus 2, see this, unlike this, the change here is in x, not in the complete function. So if you make the change in x, your graph is shifted 2 units left. If you have to sketch the graph for f of x minus 2, then your graph is shifted 2 units right. So these are the rules of translations of the graphs. In the next video, we are going to talk about the reflection of the graph.